everyone. So today I'm here to present to you one of Omdena's success stories where we used AI and machine learning to build a flood prediction model for the country of Bangladesh. Before we get into how we did it, let me first set up the context of why flooding is such a serious problem when it comes to Bangladesh. So Bangladesh as a country, topographically, its elevation is very low, very close to sea level, while all its neighboring regions are of a higher elevation. This means that there is a sort of bowl effect, right? Where water that comes in through rivers into Bangladesh, the only way for it to leave Bangladesh is through the ocean. In addition to this, the amount of water coming into Bangladesh through rivers is very high because most of Bangladesh's land is a delta formed by two of the largest rivers in Asia, meaning the Ganges and the Brahmaputra. Now, having a large river delta in your country has advantages, but it also has disadvantages. As far as advantages are concerned, the land in Bangladesh is one of the most fertile land for agriculture in the world, which means that all this food has led to Bangladesh being one of the world's most populous countries with more than 170 million people living there. But the flip side of this is that any flooding that happens either through rainfall in Bangladesh or any flooding event up either river, all of that leads into Bangladesh and causes flooding there as well. Now, another factor that comes in here that is making this situation worse is climate change. Because, as I mentioned before, the main outlet for water to escape Bangladesh is through the ocean. And with the sea level rising, the rate at which water escapes Bangladesh becomes lower. So this creates a perfect storm of conditions that make flooding an extremely serious problem for the people of Bangladesh. That's why we set out to build a flood prediction model that can help Bangladesh respond to these disasters better. And how we did it was we collected two types of data. First was historical data, where we got the rainfall and flooding data in Bangladesh for the last 30 years from their climate service system. And we compiled all of that and we analyzed that through a technique I'm going to come to later. And we collected GIS data. GIS stands for Geographic Information System, and that is data about the land itself. So that's elevation, slope, curvature, land use, land cover, soil types, land surface temperature, and more, right? Anything that matters when it comes to land. And with all of this data, you get to form the current landscape, the current scenario of the different types of land in Bangladesh. Now, we took all this data and we put it into a model that performed exploratory data analysis, which is a method of compiling and analyzing all of that data and finding patterns, right? With historical data, we basically, we got a better understanding of historically what are the regions of Bangladesh that have been more prone to flooding and higher rainfall. And we also got a lot of data about the trends of rainfall in Bangladesh, which from this graph looks very random, but it allows us to, in the background, implicitly measure global weather currents and basically know and use that as a variable when we're predicting how much it's going to rain. So that's the historical data. And with GIS data, we basically took an understanding of what type of land cover there is in Bangladesh. Now, if it's water or, something like high water content soil, these lands are going to be more prone to flooding because, of course, water bodies accumulate water, and damp soil with a lot of water content already is bad at draining water. So that way we know which areas would be more severely hit in the situation that flooding happens. On the flip side, when it comes to sand content, sand is coarse and dry and it drains water significantly better. So areas which have more sand content in their soil are better equipped to drain that water away. We also measured land surface temperature. We even did it at night, and you might be wondering why, but that's because knowing the lowest rate of evaporation that water is going to experience lets us know how much water will be removed from a flooding situation through evaporation. So we took all this data, we asked the AI model to find the patterns, make predictions, trained it on 80% of the data, and tested it on 20% of the data. And we found that our rainfall prediction model using historical data, we made it accurate to a margin of error of 2.8 millimeters per day, which is extremely good. Knowing when it's going to rain and how much it's going to rain allows you to know when it's going to flood. And from the GIS data, we basically we found out how severely some area will be hit by flooding, and how, of course, that area needs more infrastructure to respond to flooding as well as prevent flooding in the first place. So with that, we created a UI for anyone, even without the ability to read the database and form insights, to view this map and know which areas that need the most help and are most vulnerable, right? And this allows the government or organizations in Bangladesh to dedicate their resources when it comes to battling floods in the key areas where it is most required. And with climate change worsening the conditions of Bangladesh's flooding every year, every rainfall cycle, it is like knowing and predicting flooding conditions is the difference between life and death for a lot of people. So we're hoping that this model can get a lot of use in Bangladesh and save lives. And yeah, that's how we went about doing it. So thank you for your time, and for more case studies like these, more success stories like these, please tune into our blog and our social media accounts. Thank you.